Hello, today I will prove Lucas' theorem, which tells us that if we want to find m choose n modulo p, then we need to look at only their prime representations in powers of p. To prove this, we need to use this lemma called freshman's dream. 1 plus x to the p to the I equals 1 plus x to the p to the I modulo p. To prove this, we need to use the fact that p to the I factorial over k factorial times p to the I minus k factorial. This number is always divisible by p. We can prove this by vp of p factorial. If you will be interested, please write in the comments and I will try to record the video about this. Now let's write generating functions about m choose n, and n is from 0 to m, x to the n. This clearly must be equal x plus 1 to the m. This is binomial expression of this one. Now instead of m, we can write mk to the pk plus mk minus 1 to the pk minus 1 up to m0. So this equals 1 plus x to the mk to the pk plus up to m0. And clearly this is the product of I from 0 to k, 1 plus x to the p to the I, then power of m to the I. Now we will need to use this freshman's dream here, 1 plus x to the p to the I. Clearly this equals from I 0 to k, this sum, we get this is 1 plus x to the p to the I to the mi power. Now we will need to use this binomial expression here, so this equals I from 0 to k sum from ni equals 0 to m mi choose ni multiplied by x to the p to the I times n to the I. Now we can use the fact that if we take mi, choose mi plus k, this number is always 0, and clearly this must be equal product from I 0 to k multiplied by the in this sum instead of mi we can write p minus 1, because nothing will be changed if we take ni from 0 to p minus 1. We will add only 0 coefficients. Ni 0 to p minus p, or p minus 1, it has same meaning. P minus 1, it has no matter for us. Mi, and choose ni, then x to the pi, p to the I, times n to the I. From here we can conclude that this number will give us sum of all numbers from n equals 0 to m. In these brackets we must get the product m choose I from 0 to k, but we need x to the n because we need to represent n in a different form. In this case, some of these numbers must be ni. So we have concluded that these two numbers are same. So modulo p. This means that m choose I, mi choose ni product, this must be equal to m choose n.